So 26, and this was our combination, our counting question. I think lots of students were counting with their fingers and trying to find different ways which you can do it. But the key thing is to try and find, how many different ways. So we don't want to count any of these routes twice. So the way we're going to do it is using a bit of a tree diagram to go through and really clearly list the different ways we can go. Now, in terms of understanding this question, we need to start at A and we need to go across all of the other points. So from A, that's the beginning of our tree diagram. We're going to start at A. So we need to think, where can we go to? So we can go to B, we could go up to E, or we could go across to D. So let's think about all of the possibilities if we were to go to B. Now, from B, you can either go to E, you can either go to C. Well, you only have two options because you can't go to D straight away. You can't go across. So we can either go to E first, or we can go to C. Now, we need to find all of the routes. So let's think about if we were to go to E, where could we go next? So tracing along, you can use your finger if you like. You can go from A to B, up to E. You have two more choices, C or D. We've got A, B, E, up to C, or A, B, E, oopsie, C or D. Okay. Now, what about if we went to C instead of to E? So we go A, B, C. You've then got two choices. You can either go from upwards to E and then D, or across to D and then up to E. So we've got C, E, D, or actually let's keep those with the arrows. E, D, or D, E. Hopefully you're still following. So what we've found is there's 4 possible routes in total to go from A and touch every single vertex if we go through B. But remember, we could also go through D. Now, D is exactly the same because if you think about it, it's just going in the opposite direction. So I've got another 4 routes to go through that one. And I think I'm going to skip going through all of those routes. So please let me know if this is something you need me to go through. Maybe at the end, I can go through all of those routes again, but they are all exactly the same going through D. You could imagine from D, you could go from D to E or DE to C. And then from there, you've got 2 routes from each one. So there's another 4 routes for this one. However, there's another possibility. We've not got them all just yet. So from A, we had options B, we had options D, but we could also go upwards to get to E. Okay, now E is slightly different, and I think this is probably the tricky part of this question. So once you get to E, thinking about where we could go downwards to D, we could go downwards to B, but if we go downwards to C, we come across a bit of a problem because now I can't go to all of the other vertices. From A to C, if you were to choose to go along D, it's impossible to get to B without touching something we've already got to. So when you get to E, there's only 2 possible ways you can go, which is A, E, B or A, E, D. I'll try and use my pen to show you which ways. So you either down there or down there. You can't go over the hill to C. So from A to E, we can go B or D. Now from B, you've only got 1 route, which is then CD, and AED, you've only got 1 route, which is CB. Now I know that's a little bit complicated to follow all of my letters, but if you need to, have a little screenshot or have a look and then play around with your finger at all the routes, and you can sort of see how we can count all of the routes and make sure we've counted every single one using this tree diagram. So hopefully that's cleared up that one a little bit, but I would say this was a really difficult question and many students struggled with this question. So when you approach these types, just try and write a list of all the possible routes and see if you can get every single one, okay? Now, next one, question 25. Now, this is actually something that we're teaching this week in class on volume. I think maybe some of you that have already had your lesson 6 this week might recognize this, but you've got volumes of cuboids, okay? So we're trying to find the dimensions. Well, we've been given the dimension of this big box, and we want to know how many cubes there are in the third box. So first, we need to find the dimensions of these smaller boxes. So the way this question works is these boxes fit exactly inside the bigger one. So you could imagine that this box is going to go inside there and fit perfectly. So thinking about the dimensions, that 22 centimeters, which represents the length, is going to be 1 centimeter smaller on the right side and 1 centimeter smaller on the left side, because these boxes are made from centimeter cubes. And so it's going to be 2 centimeters shorter in total. It's going to have a length of 20 centimeters. Now, the same we can say for the width. Okay, it was 9 centimeters, but the smaller box is 1 centimeter shorter and 1 centimeter shorter on the other side because of the thickness of the walls. So you've got 7 centimeters for that one. Now, the height is where it gets slightly more interesting, because we're not going to take off 2 for the height, okay, because the tops are completely level. So if you imagine taking this smaller box out of the big box, you lose this 1 centimeter gap at the bottom, which makes the bottom of the container. And so that height is not going to be 12 centimeters, it's going to be 11 centimeters. So that's the idea for how the dimensions work. So we can use that to find the dimensions of the smaller box. 10 centimeter height. Remember that you lose 2 centimeters from each side, so that becomes 5 centimeters. And then the length becomes 18 centimeters. Now we can actually find the volume of this box using our formula for volume, which is length times width times height. Now, if you've not had your volume lesson this week and you've still and you've not learned about volume in school yet, then please do not worry. I think this question is going to become a lot more familiar once you've had this week's lesson on volume. But the trick is, okay, it wants to know how many cubes are used to make the third box. Well, as this is made from centimeter cubes, I can find the volume of this whole box and remove all of the volume from this space in the middle. Okay, so actually you need to find the next box or cuboid that's going to go inside, and we can find the dimensions of that by using our next trick. So it's not even giving us a picture for that. So it is quite tricky to spot that next step, but you do need to find the dimensions, which is now going to be 1 less height, 2 less length, which is 16 centimeters, and 2 less width, which is 3 centimeters. And you need to subtract that volume. So all in all, our calculation is going to be 18 times 5 times 10. And then we need to take away the volume from 16 times 3 times 9. Now, I am aware that I've probably gone through that quite quickly. So if there are specific questions or I've not really explained fully, then feel free to let me know at the end when I give everyone a chance about questions, and I can try and do another explanation as to how this is actually working. But doing our calculation, 18 times 5 gives us 90, adding our 0 for timesing by 10. I'm going to take away this one. Now, 16 times 3 gives us 48, and 48 times 9, well, you can either use some multiplication skills to times it by 10, or you can do a quick long multiplication to find that you get 4 9s are 36, add your 7, which gives you 43. So we're taking away 432 for that one, which gives us an answer of 568. Oh, 468 cubes almost. 468 cubes. So because we've thought about this as volume, okay, we've worked out the number of little centimeter cubes. Each one is a cubic centimeter, and we've taken away all of the volume from the smaller one. So you can imagine that gives you just the container that you want. Don't understand. Okay, I will come back to that one. Which bit is it that not understanding? Could I have maybe the rest of you guys give me some input in the chat box? Maybe give me a 1 if you're happy with this question, and a 2 if after my explanation makes sense. You can just type in the chat box. You can pop in a message for me.
Why are we subtracting it?
Why are we subtracting? Okay, good question. So if you think about, let me get rid of some of these things so I can use my pictures. Look at the big box, this big box here. Now, this smaller box fits exactly inside. So you could imagine that we've dug it out, this one here, and it fits exactly inside. That's what it tells us in the question. The set of boxes fit exactly inside each other. So if you were to find the volume of these measurements, you're finding the volume of the whole cuboid, not of a box. So as if this was a whole shape. And then if you take away the volume from this smaller one, you're getting rid of all of this space in the middle that you don't want, and you're just finding the volume of the actual container. So that's why I'm taking it away. So I'm finding the volume of that space in the middle that I don't want, and I'm taking it away from the volume of the whole cuboid. So thank you, Doris. I think I've just written the wrong number here, but you're exactly right. I've just done the subtraction wrong. 468. So hopefully you are understanding the steps there. 468. And I also hope I've explained a little bit about why I'm subtracting. Thank you very much, Doris. Okay, so I'm going to move on. If you do need me to help with that one in terms of why I'm subtracting and why I'm finding the volume, then let me know at the end and I will go through that one as well in more detail. But next one. Now, this was a bit of a clever one, and there's a couple of ways we can solve this. I know lots of people probably tried trial and error to try different numbers and find out what the value of this fraction is. This question says the sum of the numerator and the denominator is 31. And if the denominator is increased by 5, the fraction becomes 1/2. So the trick here is to consider what is our sum. Let's write sum of numerator. No, let's just write the sum. The sum is 31. Once we've added 5 to denominator, the sum is going to change. Okay, so our sum now is no longer 31, it's going to be 36. Now, whatever fraction it is, I know it's equivalent to 1/2. So it's going to be some variation of numbers, whether it's 2/4, 3/6, or I'm not sure what it is yet, but I know that the sum is 36. So if we think about that in parts, now I've got 3 parts in total. 1, and then my denominator is twice the size as my numerator. So if the 3 parts represent my sum of 36, then 1 part is just going to be 12. And you can use that to find your fraction. Well, this is your new fraction, which is going to be 12 over 24. And that's once we've added 5. So that's equal to 12 over 19 plus 5. Because we found out the relationship once we'd already added 5, which was our fraction once we've added 5. So you know that the original fraction has to be 12 over 19. Okay, now this one is, I think, the main sort of mistakes that happen in this one is just little mistakes in adding up. We're adding up quite a lot of different numbers and money and things like that. But we're starting off with £50. Starting with £50, we use it to buy a book for £11.99. I'm going to start to write these down because these are the things I need to add up. He buys some stickers for 50p. Okay, we're making sure you line that up in the right column. He then goes to a restaurant and he orders a £17.99 pizza. Okay, so we've got £17.99 together with 6 glasses of orange juice for £1.50. Okay, so 6 times £1.50 is £9. So that's the last thing you need to add up. I've added together all of the things that Bob has bought, and I need to know how much change he's got. So whatever that number equals to, I'm going to subtract that from 50. Now, in terms of how we add these together, you can add it up as a bit of a column addition, but with all these 99s, there's a horrible amount of carries. So what I would suggest here is to spot that these are very similar to nice whole pounds. £12, £18, 50p, and £9. And we can add those all up in our heads. 12 and 18 make £30. Add the 9, that makes £39. Add the 50p, you get £39.50. Now remember, I added on 2 pennies here. It wasn't £12, it was £11.99. It wasn't £17, £18, it was £17.99. So make sure you take away 2 pennies from your answer and you get £39.48. Okay, so that's the total amount that Bob has spent. So we want to find the change. So that means you need to subtract it from 50. You can do that in your head if you can spot it, or you can do a column subtraction, and the answer should be £10.52 for that one. Just check the chat box. Okay. So I think that one should have been fine on the whole. So it's just to be super careful with our counting and maybe look out for that trick with the money, with the whole number of pounds. Okay, so next one. Right, a fraction one. Now, on the whole, the fraction ones were done very, very well. I think this one was a slightly more tricky fraction question. And the reason is because it requires thinking really carefully about which fractions we're talking about and what each fraction represents. So here, Lily spent 1/6 of her money. But this first question is asking how much money Lily has left. But if Lily spends 1/6, what fraction does she have left? We need to find that corresponding fraction. She's got 5/6 left. So that's how much, as a fraction of her money, she has left after she bought the cakes. So then, in the next part, she spends 3/5 of the remaining on egg tarts. So that means she spends 3/5 of that fraction on egg tarts. I want to know how much she has left. So if she spends 3/5, what fraction does she have left? It's 1 minus 3/5, which is 2/5. So you guys have to find 2/5 of that remaining money. So that's 2/5 of 5/6, which when we find a fraction of a fraction, we times them together and you get 2/5 times 5/6. And with some nice simplification, you get 1/3. Okay, so that's your answer to that question. It should be 1/3. How much did Lily spend altogether? Now, the easiest way to do this one is to think, if Lily has 1/3 left, then she's spent the rest, 1 minus 1/3, which is equal to 2/3. Okay, well, I know that 2/3 is how much, well, 2/3 of what? I don't know how much she started with. Well, I know that 1/3 is how much she had left, and that is represented by the £4.20. So if 1/3 of the money is £4.20, then you can find 2/3 by doubling it. That's 1/3, so 2/3 is going to be 2 times 1/3, 2/3. So we're going to have £8.40 for that one. Okay, that's how to solve that question. Checkbox. Of means times. Of, when we're talking about a fraction of another number, of is you're pretty safe to think of means times. So if you want to find, you know, a fifth of a whole number, you can times them together. If you want to find a fraction of another fraction, you can times them together. So I do think, yeah, of is a good thing to look out for with fractions, to replace with times for sure. Of equals times. Oh, I see a few people asking me that one. Yes. You can kind of think about it. If you wanted, you know, if you wanted 2 of something, 2 of 1/5, you'd find 2 times a fifth. But if you want to find a fifth of a fifth, you would do 1/5 times a fifth. So in answer to your question, I'm going to say yes. Okay, a few 2s. Is that about this question? Let me just quickly summarize what we've done in this question. So we need to really carefully think about whether or not the fraction is talking about how much we've spent or how much we've saved. So this question is all about how much is left, but the fractions they give us, and I'm going to clear some of these things to have some space, the fractions they tell us is how much is spent. So whatever we spent, the rest we saved. So 1 minus 1/6 marks the rest. If you're confused about that bit, 1 represents 6/6. You can think of it like a piece of pizza with 6 slices. 1 is every slice, 6 out of 6 parts. I want to take away the 1 part that we've spent to give us the 5 parts that we've got left over. So that's the same as saying Lily saved 5/6 of her money. And then she saved 2/5 of the remaining money. So you just need to find 2/5 of 5/6. So I hope I've slightly answered that question there. Question 10. I will get to 10. I'm just going through from the back at the moment. 22. What are we on now? 22 equals. Right, I can see a few questions, but I'm not 100% sure what the question means. So perhaps I'll come back to that one at the end if you want to let me know a bit more specifically which bit you're confused about. Is it the whole question? That's in answer to some of those chat box questions, but I will come back to that one. But as I think a lot of us have an hour, I'm going to try and get through a general synopsis of a lot of the harder questions, and then I'll give a chance for individual questions at the end once some people have have had to go and things. Right. 21. Now, I think with these questions, this is kind of like a function machine question. Okay, so thinking of a number, I'm not sure what that number is yet. I'm going to subtract 7, and you're going to times by 5, and then you're going to add 3. And you know that that number is exactly the same as what we started with. So normally with these function problems, you'd work backwards. You'd use the inverses to do -3, divide by 5, etc. However, in this question, I don't know what to start with. I don't know what that number is I started with. I don't know what that number is I'm going to finish with. So it's a good idea here is to use the letter X, to use some algebra to represent something we don't know. And then we can set up an equation. So you can imagine as X goes through this machine, once you subtract 7, it becomes X minus 7. Then we're going to times by 5. So you need to multiply that whole thing by 5. That becomes 5. Well, let's expand it all out in one go. 5x minus 35. Anyone that's confused by how I jumped that step, I've just multiplied through the brackets 5x minus 7. So I've expanded those brackets to times everything by the 5. Then you add 3, so you get 5x minus 32. Okay, but I know that this is exactly the same as x. It's the same as the original number I think of. So you've got an equation here. You've got an equation now, 5x minus 32 should be the same as x. So by solving, taking your x's to the same side, you get 4x is the same as 32, and that tells you that x equals 8. Now, popping that back into the function machine, you can see if you plug in 8, take away 7, you get 1, multiply by 5, you get 5, add 3, you get 8, just like we started with. So that's a good way to solve that question. Is it an inverse question? In answer to your question, these function machines, they are an inverse question, but because we don't know the starting number and we don't know the finishing number, it's a really good idea to use algebra here to represent those numbers and set up an equation. Okay, you do need to use your inverses when you're solving the algebra though. Okay, there's probably a few other ways that we could do to solve that question, which would be to trial and error, but again, that takes a lot of time. But there are other ways you can solve it. If you're not sure, you could try a few different numbers and see if eventually you get one. Or you can set it up in this way. I see a couple of 2s in the chat box. So essentially, the reason I'm using algebra is because I can't work backwards without knowing what I started from. So I've used a bit of a function machine here. You don't need to write out all of the steps like I've done them. And when you get to the end, you know that that has to be the same as what you've started with, x. It told you that in the question. You get the same as the original number I think of. So going through the process of what happens to x, thinking about each thing. When you take 7 from x, it becomes x minus 7. We can set up an equation and solve it to find this one, okay? Hopefully that's turned some of those 2s into 1s. Why is 32 not 38? Okay, nice. I think because, let me do that in a few more steps then. I'm going to go through that function machine. So x minus 7, when you times by 5, you're going to get 5 bracket x minus 7. Now 5 bracket x minus 7, when we times by brackets, remember we teach it a bit like a shopping bag in class, you want to times everything by the brackets. So you have 5x minus 35. And then the next stage in the function machine is to add 3. Now minus 35 plus 3 is results in minus 32. You can think about that on a number line. So your 35 spaces before 0, when you add 3, you get 3 bigger, 3 closer to 0. Okay, I can see a few 2s still, but we will come back to individual ones at the end. But I do need to get, I've still got 20 more questions to try and give you all a brief skimming through. Right, I think this one, I think everyone I saw did a really good job of spotting that this is about the lowest common multiple, okay? You want to find how many ways could I divide this number of blueberries between the different groups of people. But the trick here, and it is a common thing which comes up in these types of things, is to notice that we're sharing with friends. Now, if Bud is to share with 2 friends, how many people are we sharing between? It's not 2, it's 3. How many people do we share with? If we share with 4, we're sharing between 5 people. And if we're sharing with 6, we're sharing between 7 people. So I think if you found the LCM, then very well done for spotting this as a lowest common multiple question. And if you went for 12, you know, it's completely understandable. So just for next time, look out for these kind of things. It's a common trick. In our class, we did a few of these questions when we taught lowest common multiples, where we're sharing with 2 people and things. So it's a good thing to look out for. And the lowest common multiple of 3, 5, and 7, as they're all prime numbers, is just the product, which is 105. You can use your bus stop method or any method that you have for finding the lowest common multiple for that one. Yes, lovely stuff. Now, number 19, I will go through this one quickly. Now, this is a multiplication puzzle where we've got some missing letters. Okay, so we've got BA and times in it by B6, and that's going to be equal to AB00. So with these problems in general, it's a good place to start is the units digit. Okay, just as you would do a long multiplication. Now, the first thing you multiply together is A times by 6. Okay, and you're going to get an answer which ends in 0. You need to ask yourself, what multiple of 6 ends in 0? Go through your 6 times table, think about them. There's only one, okay? And it gives you 5 times by 6, which is 30. So you know that A is 5. So I'm going to replace those A's with 5s now. So now, oh, that was a 6. That was a 5, and that was a 0. So next, looking at what you've got, we know that these 2 B's are the same, something to 5 and something to 6. So what could that be? Well, looking at our times table, if these were 70s, well, I know that 70 times 70 gives me 4,900. Now, it could be that because this is bigger than 70, it's 75 and 76. So it's in the right range. Let's see if it could be in the 80s. 80 times 80. Well, 80 times 80 gives me 6,400. Okay, and that's already bigger than my answer. It starts with a 5. So the key thing here is to realize it's in that range. So it's got to be in the 70s. That tells you that A equals 5 and B equals 7. Okay. So it is quite a tricky one, that one, but you've got to go through, look at the units digit, look at the thousands digit, in this case, the last digit, that quite often gives you a clue. You can see 1.5s, which means you've understood the general method, but not quite sure how to apply it to other questions, I guess. It's just going through, treat it like a long multiplication. The first thing you would do is 6 times by 5. Okay, and these kind of things come up lots and lots. So, you know, keep practicing these styles of questions. They're useful tricks to look out for. I think now you know, just look out for these kind of things. You guys should all be able to find that A is 5 by looking at what value of A times by 6 gives you a number ending in 0. And then the only other thing that can give you a clue, because if you look at the next multiplication, 6 times, I'll try and get a pointer. Once you've done 6 times by 5, oops. Once you've done 6 times by 5, you would then do 6 times by B. 6 times by B, that doesn't tell you anything, giving you a 0. It doesn't really tell you anything, that one. So the next thing you can really look at is that last digit. So that's the thing to look out for there. I do see a few 2s. I will come back to that one at the end if you need to. Right, blueberries. I think we went through that one. It's not letting me change page. Here we go. Done that one. Okay, this is quite a nice one. I think there was a few problems with this one along the way. Now, when you see a question like this, a sequence starts with -1 and increases by 3 each time. Now, this is not a sequence that we're familiar with. So let's start by writing a few steps out, seeing if we can look at the numbers. 1 increasing by 3. So you get 1 to get to 0 and 2 more to get to 3. So you get -1, 2. Adding 3, you get 5. Oh, adding 3, you get 8, and so on. 11. I'll just write a few more out. And then you've got the sequence. You can find the first prime number. So a prime number is any number that has 2 factors, exactly 2 factors, 1 and itself. So going through this list, you can have a look for them, but the first one is 2. It's our very first prime number. It's our only even number. It's not our only even number, our only even prime number. And you guys should be familiar with some of the prime numbers, at least the first few smaller ones, okay? And especially this even prime number 2. So that's our first prime number. A cube number. So whether you know your cube numbers and you can spot it straight away, or you want to try a few cube numbers out, you can try 1 cubed, which is 1. You can try 2 cubed, which is 2 times 2 times 2, which gives you 8. And we've got our first cube number already. And then the first multiple of 10, that's a nice easy one, okay? So I think the trick for this one is just to go through and to list some of the sequence out and go through, have a good understanding for what prime numbers are, cube numbers, and you all know what multiples are. Just having a flip through the chat box. You missed 19, 2, 8, 20. Yes, 2, 8, 20 is the answer for that one. Okay, I saw someone miss 19. 19, I'll just show you, see if you did miss it. That was the puzzle one. So if you want to ask me at the end, I can go through that one again. Right, cycle problems. I will go through this one as there was a few problems with this one. This is not something we would have taught since about year 4, so it's completely understandable. Many of you have forgot it. It will come up again. This is a periodic problem, a cycle problem. Okay, it's about the days of the week that repeats every single week. So no, you don't need to count the number of days between September the 27th and Christmas Day. We're going to use some maths here. So we do need to know the number of days. So you need to think about how many days there are in September. So whether or not you're using your knuckles to find the dates in the month, or you use the rhyme, 30 days has September. We know that there are 30 days in September. So that means there's 30 minus 27, which is 3 more days. Then we've got all of the days in October. So there's 31 days in October, which you probably all know from Halloween. Then we think about November. We've got 30 days in November. And then we think about the last 25 days in December to get to Christmas Day, which is the 25th. So that's the number of days, which is 3 plus 61 plus 25, which gives you 64 plus 25, which is equal to 89 days. But you don't need to count on 89 days from a Thursday, because every week this repeats. So let's find out how many weeks. So I divide it into 7. You see, this is the same as 12 whole weeks with an extra 5 days. Now, this extra 5 days is the only thing you're interested in, because you know it's 5 days beyond the end of the week. So count 5 days on. So you've got Friday, Saturday, Sunday, Monday, Tuesday. And your answer is Tuesday. So if you think about this, if you think carefully, if this gave you an answer without a remainder, for example, 12, that's 12 whole weeks, exact weeks. So you're going to end up on that Thursday. So a remainder 1 would represent the next day, remainder 2, 2 days later, remainder 3, 3 days later, and so on. That's a bit of a trick to that one. Okay. 31 days in September. No, there's not. It's 30 days in September. I prefer adding days and months in between September. So yes, there are a few alternative ways to do this, adding the days and months in between September. So I'm assuming you're meaning you can count from the 27th of September up until the 27th of October, then to the 27th of November, then to the 27th of December, or I'm finding the difference of the days of the weeks. Right, JR, I'm not 100% sure. You prefer adding the days and months in between September 1.3 and adding the amount of days. Okay, I'm not entirely sure what you mean by that one. I know there are a few different ways you can think about this, But as long as you're finding the number of days between the 27th of September and the 25th of December, and you're getting 89 days, and then you can do your cycle problems to work out it's just 5 days beyond the Thursday. There's no way that we need to try and count on days like in a cycle, because that's why that's what this question's all about, is spotting it. It's a repeating pattern and using that to solve the problem. Okay, right. What are we doing? Question 16. Now, I will go through this one as there was quite a few mistakes. I think this turned out to be quite a tricky one. This is one of these work done problems. So an octopus has 8 legs, 4 pairs. Now, all we know is that each pair of legs, I'm going to write down that information, one pair of legs takes 15 seconds to open 1 jar of jam. So with these types of problems, we want to try and change one thing at a time, so we can try and scale it up and find out how much one octopus opens in 3/4 of an hour. So the mission is to get to, I'll leave that till the end. First, let's try and find out how much one pair of legs can make in more than 15 seconds. Let's try and find out how many it makes in 45 minutes. Well, if I tried to find out how many 45 seconds there are in 45 minutes, sorry, how many 15 seconds there are in 45 minutes, that would be quite a difficult division. So first, let's think about how many jars one pair can make in 1 minute. So 1 minute is 4 times by 15 seconds. So that means it's going to make 4 jars, 1 times 4, okay? Because it's 4 times the amount of time, and every 15 seconds it makes 1 jar. So that represents 1 minute. So how about how many jars can one pair of legs make in 45 minutes? So that's 45 times as long. So it's going to be 4 times by 45 for that one, which is equal to 180 jars. And then we're almost there. So changing one thing at a time, I've got the right time. Now I need to change the number of pairs of legs. So an octopus has 8 legs, that's 4 pairs. So 4 pairs means they're going to spend the same amount of time, 45 mins, but they're going to make 4 times as many jars. So that's 4 times 180, which is equal to 720 jars. So that's how to solve that one. 720. Okay. 7. Yes, I can see a few answers. Yes, 720. Great. I mistyped miss. Oh, you're talking to someone in the chat. Okay. Well, hopefully I've cleared up that question. I think it's quite a nice question, this one, once you've got the steps. So going through and making sure you change one thing at a time and changing it until you get the, how much 4 pairs of legs can make in 45 minutes. You can do it all in one go if you're feeling confident with the relationship, and you can see that you need to times the number of legs by 4 and the number of seconds by 4 and then by 45. So that's 180 times the number of seconds, I guess, if you wanted to do it all in one go. All right, next question. So, which one? I think number 15 on the whole was okay. I think the median was the difficult part with this one. Now, this is about different types of average. Okay, so this is a table showing the scores in 12 tests. So the first part is we need to understand what this table means. So on the top, you've got the scores, 7 out of 10, 8 out of 10, 9 out of 10, 10 out of 10. The frequency is the number of times these scores appear, the number of times people score them. So 2 people scored 7, some number of people scored 8, 5 people scored 9, and 1 person scored 10. So how many times did you score 8? Well, we know that there's 12 people. The frequency table shows Bud's score out of 10 in 12 weekly maths tests. So there's 12 tests. So that needs to add up to 12, the frequency. So you've got 2 plus 5 plus 1 gives you 8, which means there's 4 missing there. Now the mode, that's a nice easy one, because the mode is just the most common number to come up, which is 9, because it comes up the most number of times, 5 times. So that mode is 9. A nice way to remember that is the MO is the most common. The median is the middle value, okay? the middle value. So that means we put all of the scores in order. You could have, you don't need to put them all in order, but you can, just so you've got a good understanding. There's 2 7s, 4 8s, 5 9s, and so on. Now, I want to find the middle value. Okay, so I've got 12 values here. So the middle is somewhere between the 6th and the 7th value. Now, a way you can work that out, and a little bit of a trick, if you can't spot which number is the middle value, is to add 1 and divide it by 2. So that tells you that it's the, if you do want to use that trick, it will give you the 6.5th value. So it's halfway in between the 6th and the 7th value. Now, if these are, I think this is just a little trick that I use to find the middle value. I think if you can spot it in other ways, I think, you know, you can imagine if you've got 5 values, the median is going to be the 3rd one. You want to have the same number of values on each side. It's the middle value. And obviously, if it's an even number, for example, we had 6 values, the median is going to be somewhere in the middle of those 2 values in the middle. So here, 12 values. I want to find the value that's in between the 6th and the 7th. Now, I know from the first question that we had 6 values in 8. So that means you're, oh, sorry, not 6. I've added the 2 already. 4 values that came up in 8. So that means your 6th value is an 8. 1, 2, 3, 4, 5, 6. So your median needs to be halfway in between the 6th and the 7th value. So it's 8.5 for that one. Okay. When end? I aim to end at 5, but I will run over for questions and things. So I'm happy to stay for a little bit later. So it's up to you guys if you want to stay and ask questions in answer to that question about when this ends. I was aiming to finish it by 5, but I've gone through quite a lot of these questions. I wanted to prioritize the harder ones. But yeah, I will run over. So if you do want to stay, and I am recording this session, so if people do have to go and want to catch up on other questions, then feel free to watch the recording as well. Right, 14, I won't go through all of this one, as I think on the whole, these ones were okay. At least 1, 2, and 3 were done very, very well. Number 4 was a bit of a mean sequence to spot. Most of these ones are standard patterns, so you can look at differences and you can see what's going on. But this 4th one, can't find any differences. I'm sure lots of you looked at the differences. When you see this kind of sequence where, you know, the differences aren't making much sense, it's not one of your common patterns, they're not increasing by the same amount each time. It's another thing to look out for is 2 patterns running at the same time. So here you've got these negative numbers going on. Now, spotting the pattern there, these negative numbers, each time they're getting twice as small, well, twice as big, if you arguably, or timesing by 2 each time. So -2, double that is -4, double that is -8. The next one will be -16 for that one. Now, looking at the other pattern, which is running alongside it, we've got 1, 4, 9, 16. 1, 4, 9, 16, you can find by looking at the differences. So you get +3, +5, +7. So the next one is +9. But it's much easier to spot. These are all of our square numbers. So the next one is just 5 squared, which is 25. Okay, so it's a nice thing to look out for, and that one is those kind of patterns which are 2 patterns going at the same time. And yeah, I think once you know that that's 2 patterns, it's much easier to spot what's going on there. Okie dokie. So next, now I won't go through this one. This is just algebra solving. If you do want me to go through this one, I'm happy to go through after, but I want to get through some of the common mistakes so that everyone can have a good analysis of the paper. This one, the geometry question, I think this was done very well on the whole. Number 11. I'm going to skip this one as well. It's another fraction one. I think everyone did really well in the fraction ones in general. This one, just the trick, in case it helps you, and this will give you a clue, is this number, the 48 cupcakes, is not representative. It's not represented by this fraction here. That's how much fractions we had left. Okay, the fraction she gave away is 1 minus 4/7. So that's the trick to that question. If that helps. Right, I will go through the magic square one. This is something we teach, we've taught in year 5, probably not taught for a little while. Teaching year 4 as well, sorry. Now, magic squares is a common type of thing to come up occasionally. No, not common. It comes up every now and again in 11 plus papers, and it's really handy to know a few of the tricks. Sorry, I'm just trying to clear these drawings. Now, the key thing with the magic square is that all of the rows, the columns, the diagonals add up to the same thing. However, we don't know what any of them are. I can't work out what any of them are because I don't have 3 in each row. So what I do have is something we call intersecting lines here. Those of you that have learned about this with us already might be a little bit familiar with this, but you've got 2 crossing lines, and within those lines, you've got 4 of the you've got 3 of the numbers. I'm going to show you the trick here. We're going to represent this missing one in the middle as, let's call it an X, because we don't know what it is yet. Now, I know that the sum of the numbers in this row here, which is h plus x plus 17, is exactly equal to the sum of the numbers in the column 11 plus h plus 15. That's equal to 11 plus h plus 15 there. Now, I've got 2 h's on each side. They're both part of my equation, so I can get rid of those. I can take it away from both sides. Now, if I get rid of the h's, suddenly you're left with an equation which you do know how to solve. We've got x plus 17 is equal to 26, telling you that x must be equal to 9. Okay, so that's the trick to this problem, to this question, and that gives you your missing value of 9 in the middle there, which is all you need to find out the sum of the numbers in the magic square. Now, 9 plus 7 is 16, plus 11 is 27. That gives you your sum. You can use that to find the missing one on the right column. 27, take away 11, take away 15 to give you your missing value of h, which is just 1. I saw a hand there. I'm guessing I'm going to get a few questions for this one. Okay, maybe I will come back to that one first, but I do want to, because I'm sure lots of people will have to disappear at 5, and there's about 1 or 2 more, maybe 3 questions I just want to skim through to make sure I've covered all of them. But I will come back to this one first. I can see lots of I don't understand in this magic square question. Okay, right. See a few 1.5s. I will come back to that one, guys. Right, fraction one. I'm going to leave the fraction one. We've spoken about that one already. The time one was done pretty well on the whole by everybody. I'm sure lots of you had several different methods and things to do this one. You can either turn this into hours. So we know that's 2 hours, and well, 2 hours gives us 120 minutes. So 2 hours and 55 minutes. And you can add that on to 15:55. Or you can notice that this is 5 minutes less than 3 hours. So if you add 3 hours, you get 18:55, and take away the 5 minutes to get your answer of 18:50 as a bit of a trick. You can do these like, once you've changed it into hours, you can do it like a column addition and add 2 hours and 55 minutes if you want to, but you would just have to be really careful with your carryovers, because we're no longer counting up to 100, because whenever you get to 60, that has to carry over to the hours. So you can do it like that if that's the way you like to do it. But I think the speediest way is to notice that's 5 minutes less than 3 hours. Okay. Right, this one was done very well. I think I won't talk too much about this one. The 3 lines of symmetry for this one are, we've got lines of symmetry going through the O. There's a couple. So at least one. Got no symmetry for the N, none for the R. You've got symmetry going through the middle of that T, and you've got some symmetrical lines going through the H. So your answer should be 3 for that one. Right, almost there, guys. Now, I will talk about this one because there's a trick for this one as well. Now, lots of you found the answer very nicely by realizing these are all identical rectangles. So you've got 1, 2, 3, 4 groups of 9. and then you've got 1, 2, 3, 4, 5, 6 of those little groups of 3. So you can add those up and get 36 plus 18, which is equal to 54 centimeters, hopefully. If I've added them up, I did it very quickly. 1, 2, 3, 4 lots of 9 plus 1, 2, 3, 4, 5, 6 of the little 3s. However, there is a trick, and it's the perimeter questions where you've got that step that we teach. Okay, you've got the missing, like a little corner taken out of it. And we normally teach it with the translation method. So it's this idea that this little 3 centimeter line that's part of the perimeter, if you move it up and you form part of the rectangle up here, it doesn't change my perimeter, but it does help to make this rectangle look a little bit more like a rectangle. We're going to do exactly the same for the line on the right side here. And I'm going to translate it across to the left, and it's going to end up here. Now, doing that has not changed the value of my perimeter at all. I've just moved these 3 centimeter lines towards the edge of my rectangle. You can do the same on this side, and you realize that those steps, those corners that are cut out of shapes, do not change the value of my perimeter at all. So you can just find the perimeter of a rectangle that has 3 plus 9 width, which is 12, and 9 plus 3 plus 3 length, which is 15. So 12 and 15. Using our perimeter of a rectangle, we're going to add together the length and width and times by 2 to get 27 times 2, which is 54 centimeters. So a little reminder about that trick with the translation ones. For people letting me know you need to go, as it is gone past 5 now. Thanks for coming. I hope I've managed to answer some of your questions. Very well done for completing the mock test. I am still going to stay, guys, so this is not a goodbye to everyone, and I will do some more questions. I just want to say I see some people are starting to disappear now. I wanted to say a big thanks for coming. And if you do have any more questions, please don't hesitate to get in touch with your tutor. So whether it's myself, Tiger, Kai, Eva, or Zoha, or any of our tutors, you can let us know, and we're more than happy to help explain certain questions. I will be staying around after to answer some questions as well, and this recording can be made available. So you've got lots of different options there. I can see some people waving. Thanks for coming, guys. Very well done for completing the test. You've all done very well. I know it was tricky, but we will be doing more practice. That was the first practice, and we're going to do another one towards the end of March. So we've got something to work for and practice on. Okay. Now that's just my message.
Bye.
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 Yes.
Bye. Thank you.
No problem.
Bye. Thank you.
All right.
Thank you for the lesson.
No problem. It was a little lesson.
Thanks for the
walkthrough. Glad you enjoyed, guys.
Thank you. Thank you for the walkthrough.
No problem.
Bye.
Bye-bye. Okay. Well, I'm going to go straight back in and carry on a little bit. Now this one, I do want to go through this one because this is a nice question, and I think people tended to find this one quite tricky. And this is not something we've taught to recently in year 5. I think this has come up in year 4. So some of you might recognize these ones. These are defining new operations. Operations are like plus, minus, times, divide. And these are new operations. So it's not our standard thing. So this tells us that when you do A and you do this weird operation, which is a cross with a times in it, and you apply it to B, what you need to do this operation is you need to take your value of A and you need to times it by 5, and then you need to add it to half of your value of B. So being careful here to make sure you use your bid math. So you've got to do your 5 times A together and your B divided by 2 together. So let's look at this example of 10 times, or not times 8, 10, we don't have a name for this operation, weird operation 8. So A is your 10 and 8 is your B. So what we need to do is you need to times the first one by 5. So you get 10 times by 5, and you need to add 8 divided by 2. So you need to find half of your B. So you can kind of think of your 10 as your A and your 8 as your B. So you're finding A times by 5, and you're adding on B divided by 12. Exactly as it told us, that's what the operation does. That's how you find your answer. And what the answer is 50 plus 4. So you should have got 54 for that one. So same principle for number 2, except we've got some brackets as well. So you just need to do those first. 11, weird operation, 18, means you need to times your first number by 5, you get 55. And then you need to add half of your next number, half of B. So that's add 9. That gives you 64 for that one. Okay. Oh, that's not our answer yet. That's just the brackets, almost. So once you get 64, you then need to do the same weird operation thing on 7 with your operation on 64 here. So we're getting the hang of this now. It's starting to become easier. You just need to times your 7 by 5 and add half of 64, which is 32. That gives you 35 plus 32, which is 67. That should hopefully have been your answer for that one. Question 5. How do we do? Yes. So hopefully that's answered some of those questions. I can see I got number 2 wrong. I will go through number 2. Sorry guys, I missed a few messages in the chat. Yes, I will. I can see requests. I will try and go back. Perhaps remind me at the end, as I'm missing a few of these requests for questions, but I will try to remember some of these requests. But if you remind me at the end. So big, yes, this is a big one. But in terms of what you actually have to do to those numbers, we're timing by 5 and dividing by 2. So you should, in theory, be able to do a lot of these sums in your head. For example, half of 64, we can get 32. And just work through really carefully, thinking about what's A and what's B. Times the first one by 5 and add half of the second one. Okay, you meant 2 on question 5. Okay, I think I've just gone through that then. So hopefully I've gone through that one. Vegan. Okay, nice. Next one. Almost there, guys. Fraction question. I don't think I need to go through this one unless anyone wants to let me know that they're desperate. This one was done pretty well on the whole. This fraction question. Okay. See no requests for this one. Now, this one, I think on the whole, this was done pretty easily. The trick with these ones is you need to cut all the shapes up into lots of shapes that are the same size, so we can treat it like a fraction. Now, at the moment, I've got triangles and squares. So let's cut them all in half. So now you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal squares. So how many is shaded? 1, 2, 3. You've got 3 out of 10 of the triangles are shaded. Yes. Any more to go through? Question 2. This was done pretty well. This on the whole was done pretty well. I will talk about a few of these things. Number 1 and number 2, long division and long multiplication, that's okay. Number 3 is a little BIDMAS practice. Okay, BIDMAS is the order in which we do operations. So if you can't remember BIDMAS, have a little recap on BIDMAS and the order of operations. We need to make sure that we do our timesing before you do any adding or subtracting. Okay, to remind you, BIDMAS. So our multiplication is this one, which is coming before addition and subtraction. So you need to make sure you do that one first. So it's 12 plus 40 minus 53. 4/9 of 54, that was okay. The division was a bit harder one, 3/5 divided by 7. Now in class, we learned 2 ways to solve this. You can either divide your numerator, and in this case, I can't divide 3 by 7, or you could times your denominator. So you get 3 over 5 times 7. That's the simplest way to do it. Although, of course, you can also realize that 3/5 divided by 7 is divided by 7 ones. Turn that into a fraction. And then when we divide, you need to flip that fraction upside down and multiply instead. I know lots of you use KFC to remember, keep, flip, change, or some of you use what I taught you in class. Turn the fraction on its head and multiply instead. So we're going to turn the 7 upside down and times by 1/7. And you see it has the same effect as what I did when we times the denominator, and you get 3/35 for that one. I think the rest of these were okay. Maybe the last one I'll go through with everybody is number 8 and number 7. Which these are super common ones which come up in 11 plus, and it's using the first thing they tell you to find out the second one. So 45 times 84. We know what 84 groups of 345 are, and this one wants to find 42 groups. Okay, so that means you've divided by 2. So your answer is going to be divided by 2. So you need to find out what 28,980 divided by 2 gives you. Okay, and it's 14, 4, remainder 1, 9, 0. Now, the next one was a little bit more tricky. 417 times 52 is equal to this. So if we work backwards, you know that 21,684 divided by 52 is equal to 417. So you know that if you break this 221,684 into 52 equal groups, you get 417 in each one. So what about if we wanted to break it up into groups that are half the size? So the groups are 2 times smaller. Okay, that means there's going to be 2 times more groups. You're breaking it into half the number of groups, which means each group is bigger. So it's 417 times by 2. So that gives you 834 for that one. 834. Right, I can see I've got a few requests to go through some of the harder ones again. I will start to take requests, but let me just say goodbye to everyone that's stayed till the end and doesn't need any special requests. Thanks very much for taking part in the mock tests. I hope that you enjoyed having a practice and using some of the things we've been learning in class to apply to some real questions. We will be sending around like reports of how everyone's done, so you can have a look and see the more detailed analysis of how you've done and everything. But I feel like there's lots of positives here. This was our first practice, so please don't feel too discouraged and too demotivated. You're all doing very well. Keep doing the practice. We've got lots of practice available this term in terms of the calculation books and the practice books. And all of us tutors are here to help support you in case you need some help coming up with learning plans and how you want to approach the practice questions. There's lots available, and we will be doing another practice test in end of March. So that's another opportunity